CBT Nuggets JNCIS Security IPsec VPN Part 2. Well, we're going to continue now with Part 2. We're going to get into the distinctives of Junos SRX VPN IPsec. So we'll start out making sure that we look at a couple of things that are particular to the Junos flavoring of IPsec. We'll look at some very important key terms and considerations for pre-deployment and decisions you have to make before you even start to type in your first configuration command. And then we'll go ahead and configure a IPsec site-to-site VPN with pre-shared keys between two SRX appliances. Sound good? Okay, let's jump in. Okay, let's return to a concept of flow processing that actually comes from, I think, nugget number 3 of this series, where we looked actually at the flow processing on an SRX. But how does that relate to IPsec VPN? Well, it's important that we understand where this happens in the traffic processing flow. So, let's say you create a session on your SRX. If a flow is destined for a VPN, and we're going to talk about our two main options, route-based or policy-based, here in a moment. But either way, if it's a flow that is targeted for a VPN, in other words, it's interesting traffic, it'll be sent into the VPN as one of the last steps in our processing chain. It actually occurs right before we send the traffic onto the physical media. Now, one of the great things about doing this and putting it in the end of the chain, it allows us to perform a lot of other activities first on the plain text traffic before it's either hashed or encrypted. For example, IPS, intrusion prevention systems, network address translations, application layer gateways, and UTM, Unified Threat Management. Also, the reverse can occur after the traffic is decrypted and returns from the other IPsec peer. So, just like clear text traffic, our VPN bound traffic is totally flow aware. In other words, it's enforced by this flow processing that we see here. And we can see here's where our IDP and other services occur. And so basically the IPsec tunnel is really just an abstraction layer on top of our standard processing flow. Now, I mentioned policy-based VPNs and route-based VPNs. Well, let's talk about those two things that we have here in Junos, because that really sets Junos Security VPN apart from other vendors. Okay, the SRX basically has two types of VPNs. One of them is policy-based and the other is what we call a route-based VPN. Now, if you have a Cisco security background, just in case, okay, and you're wondering how would this compare to, let's say, a Cisco router and router security? Well, the comparison would be doing an IPsec site-to-site VPN with crypto maps and crypto ACLs as compared to using a virtual tunnel interface where you send routed information to the VTI. So this is really the same comparison. Now, regardless of the choice you use, the basic IPsec operation is pretty much the same as far as the traffic being encrypted and decrypted. It really comes down to just implementation differences. Now, policy-based VPN is basically kind of leveraging the power of our firewall security policy. That's what's going to determine what gets sent into the VPN. So it's done on a policy by policy basis, and we match our traffic based on the source IP, the destination IP, the application, and the to zone and the from zone. So you see it's policy based. When we use this type of VPN, the action will be the tunnel action. Okay. Now you can also apply additional policies as well. You can apply services like IPS, URL filtering, logging, antiviruses, all those things with a policy-based VPN. Now, VPNs in the SRX are going to use what's called a proxy ID. And these proxy identifiers are going to be based on the firewall policy that you're using. So, for example, the policy's source address will actually map to the proxy ID's local identifier, the local ID. The destination address maps to the local proxy ID. And the service will map to the application that's going to be destined for the tunnel. In other words, what application traffic are you going to encrypt in the, let's say, untrust to trust zone or trust to untrust zone? And by the way, the proxy ID can be overridden Usually it comes from IPsec phase 1, but it can be overridden in the IPsec phase or phase 2 if you want to. And we use policy-based VPNs for simple site-to-site and basic remote access VPNs. Now, the route-based VPN is a lot like the Cisco virtual tunnel interface, where you don't depend on policy. Let's say, what's the destination address and the source address in the application as far as applying the VPN to it. Here, we use our routing mechanism, and whatever we route to a virtual tunnel interface, that's what gets protected. So Cisco uses a VTI. The Junos SRX uses an ST0. Okay, so they use an ST0 secure tunnel interface, and the traffic that gets to be encrypted or protected is going to be directed to that interface via some dynamic routing protocol. OSPF, for example. Now, the policy action here is not tunnel, but it's type permit with a route-based VPN. You also have the major advantages of leveraging all of the advanced dynamic routing protocol features with your VPN when you use the route-based option. The bottom line is dynamic routing protocols make it a lot easier to administer your configuration, and it makes it able to fail over to different links if necessary. And by the way, you don't have to use dynamic routing protocols. You could use static routes, okay, and still use a route-based option. So let's go ahead and just jot up here static OK. Usually though, you're going to go with the dynamic routing protocol. You're going to have proxy IDs as well. These will be manually defined for each VPN, and your STO is configured within a security zone. So the interface, the STO, is actually assigned to a security zone, just like you assign interfaces with our policy, for example. The route-based option is more flexible. However, it's definitely more complex to configure, and something you're going to look at in greater detail as you move forward in the Juniper security space. Now, what's interesting is the actual configuration of your IPsec site-to-site VPN isn't all that complicated. You have your IPsec phase 1 settings, which need to match the other side, and you have your IPsec phase 2 settings, which also need to match, and then you want to determine how you're going to route traffic between the different domains or the different networks that are actually being protected behind the devices. But there are a lot of other considerations to think about before you actually deploy your IPsec site-to-site VPN. The number one that I didn't list here, but it should be on the list, is the number one thing, is to make sure that you have underlying connectivity. In other words, if I'm going to connect an SRX to a Juniper router or two SRXs together, or maybe even a Juniper router or SRX to a Cisco device, I need to make sure that I have the underlying network, the ability for them to ping each other and actually send traffic in the clear first before I lay this VPN on top of it. That's the number one thing to consider. You don't want to do this all at once and then try to go back and configure connectivity and your VPN. So make sure you have that first. Now, along those lines, we're going to ask ourselves, are we going to use some of these particular implementations? For example, IKE doesn't have any way to tell if the VPN peer is failing during the communication. You won't even really know if the VPN has failed, at least until your keys expire and then the renegotiation occurs and then that fails. Okay? So there's a standards-based feature called DPD that can be implemented. Dead peer detection, which uses UDP protocol, basically sending kind of hello messages to the other peer. Now, typically, we'll use dead peer detection when we're doing static routing. And this should make sense, right? Because if we're using a dynamic routing protocol like OSPF, well, OSPF will both detect a failure and it can even default over to some other route, right? So typically we use DPD when we're using static routing with either policy-based VPN or routed-based VPN. We also want to ask, how are we going to monitor this particular configuration? There is no built-in monitoring in IPsec, but you can use ICMP. to tell you if the VPN is up and running. So the VPN monitoring feature will let the SRX send ICMP traffic either to the peer gateway or to some other destination as well. Now, by the way, the configuration of all of these things is really beyond the scope of this JNCIS security, but these are still considerations that you need to be aware of. Okay. Also, network transport protocol is recommended, highly recommended, especially if you're using certificates as opposed to pre-shared keys. There's also XAuth. We know that there's IKE Phase 1, and then it goes to IKE Phase 2. XAuth is kind of, what we call IKE Phase 1.5, okay? It happens in between IKE Phase 1 and IKE Phase 2, and it allows you to extend authentication to do user authentication, okay? Right now, we're just doing peer authentication. We've got a SRX over here, and we've got an SRX or a Juniper router, or 2300, let's say, and we're authenticating the peers. But what about the individual users who are actually using this VPN? What if you want to leverage something like your Microsoft Active Directory? Well, you can use XAuth to get extended authentication and add that additional user authentication. Also, when you do source NAT on your IPsec device, it's going to modify the source address. So we have to find some way to know if there's a NAT device in between our two peers somewhere on one of these routed hops. And so NAT-T or NAT traversal can discover that for us. So are you going to use NAT-T to not only discover if there's a NAT device, but also to take the original IP address and put it into a UDP encapsulated header so that you can actually get that traffic across the routed network when network address translation is being used. Next, we have anti-replay protection. Now, this is actually automatically built into IPsec. One of the downsides to IPsec VPNs is that an attacker or a man-in-the-middle or meet-in-the-middle attack can actually capture valid packets and then replay them into the network and then really mess with your VPN gateway or your host. Now, they can't get the contents of the message, but they could also use this as a denial of service attack. So IPsec has protection built into it by using a randomization of sequence numbers. Also the kind of things that firewalls do as well. There's also issues of fragmentation. When you're doing encapsulation, you're going to be adding, for example, additional information into the header. So the IP header, which can take up to 20 bytes, can actually cause fragmentation issues. So you have to think about that as well. And then finally, there's the IKE key lifetimes. You're going to create keys in IKE Phase 1 and IKE Phase 2, and you want to determine how long are those keys going to be valid for. Okay, what's the lifetime? Sometimes you have an entire day, 86,400 seconds. Sometimes it can be longer, sometimes it can be shorter. Also, in IPsec or IKE Phase 2, there's a couple of ways that you can determine when you're going to renegotiate new keys. You can do it based on time or the amount of traffic in kilobytes that's been encrypted and decrypted with the same keys. So you have lots of flexibility there, but the key lifetimes are a consideration. Usually, the shorter the lifetime, the more secure the environment. Now, like I said, one of the first things you're going to do is make sure you have underlying connectivity of your peers before you overlay this VPN. But then the next decision you're going to make when it comes to configuration is, are you going to use manual IKE keys or are you going to use auto IKE? Bottom line is, in almost any scenario, you're going to go ahead and let IKE automatically generate keys for you. Why? Because AutoKey is dynamic, and it also automatically renegotiates the keys that are used instead of using the same key over and over and over again. Another choice is to use authentication header or ESP. We're going to opt for encapsulating security payload because it provides confidentiality, integrity, and authenticity. Okay? Remember, AH does not encrypt. So over public networks like this VPN, we're going to use ESP. There's also transport mode and tunnel mode. If you're creating a VPN between two devices, let's say two SRXs, two routers, an SRX and a router, even if it's going to be some other vendor's product, then you're typically going to go with tunnel mode. Transport mode is when you have kind of a client-server relationship to a laptop, for example, or a PC, or between two PCs. You'll use transport mode. We have seen transport mode make kind of a comeback in certain environments with some new implementations of IPsec, but for the most part, we're going to opt for tunnel mode. That'll be the example we do here. Also, what about aggressive mode or main mode? Main mode is the choice you're going to use over an untrusted network, okay? Because it does peer identity. And we're going to base our peer identity on IP address. You can use aggressive mode if you're in an environment that has better protection and more of a private network, okay? Also remember that Ike version 2, not Ike Phase 2, but Ike version 2, the new version, is going to speed up this process altogether anyway. Also, you're going to be using Diffie-Hellman to generate pre-shared keying material. The Diffie-Hellman key exchange is used to negotiate Ike Phase 1 and perfect forward secrecy if you're going to do that. The larger the key, the better it's going to be, the more secure. Typically, we're going to use group number 2, even though there's all different types of groups. You've got group 5, group 14, 15, and 16. The higher the number, the larger the key space or the bit size, okay? So, for example, 2048 is basically going to give you 2 to the 2048th power of possibilities. Diffie-Hellman group 2 is probably kind of the least common denominator. There is a group 1, but you probably want to avoid that and use at least group 2. The newer your operating system, okay, the newer your Junos, the more support for different and higher groups of Diffie-Hellman with larger key spaces that are available. Also, are you going to authenticate the IPsec peers with pre-shared keys, which is the way we're going to do it, or are you going to use a certificate-based solution or a PKI? Remember, if you're using PKI, it's very important that you're using network time protocol to make sure that the devices have synchronized clocks against an NTP server. Also, if we're going to be using Ike main mode or Ike Phase 1 main mode, how are we going to identify our peers? Well, the most common way is to use the IP address method. But you can also use a fully qualified domain name. You can even use an LDAP distinguished name if you're in that environment as well. But you use IP address most often. Then, what type of encryption algorithms are you going to use? The three options are DES, which you want to avoid because it's been cracked, triple DES, which is a fine option, but the preferred option is to use AES. And we want to typically use AES 128 or 256. Again, that's the key space. So that's the option of choice. If you're going to use one of the newer versions of VPN, which is called Get VPN by Cisco or Group VPN by Juniper, then you have to use AES, okay? What about your authentication algorithms? This is what you're going to be using to do your hashing with your hashed message authentication code to authenticate peers and make sure that you have integrity so the packets haven't changed. Two options, MD5 and SHA-1, and SHA-1 is definitely preferred over MD5. You're also going to create proposals. This is Ike Phase 1 proposals and Ike Phase 2 proposals. You can use the predefined proposals that are in the Junos operating system, or you can create your own custom proposals. Also, are you in a high security environment where you need to use perfect forward secrecy? That way you're not reusing keys, you're generating an entirely new Diffie-Hellman exchange to create new keys every time you're creating a new security association. So you'll see PFS used in government and military and high security environments. And then finally, last but not least, as we talked about earlier, our two main types are route-based or policy-based. Which one are you going to use? Route-based uses a virtual interface. Policy-based is kind of based on our existing security policy. Okay, so here's our scenario. We had this little satellite office over here that has a SRX 100 and then going across some type of cloud here to a main facility or another lab, for example, has a SRX 210. Now, obviously, you can do this with two 100s. You could do it with higher end SRX devices. This is what I'm going to be using for my example. Now, what I would recommend to you, and I've already configured the other side of this, okay? But what I would recommend to you is whatever device you use as your main configuration to learn this, consider connecting your SRX to a wide variety of devices. not just another SRX. Maybe a Juniper router, maybe a 2300 series router, maybe even a Cisco device, a Cisco integrated services router, maybe a Cisco adaptive security appliance, because you want to kind of be familiar with different scenarios of connecting IPsec site-to-site VPNs, because the bottom line is you may be in environments where you're connecting to other labs, other branch offices, other partners that aren't using Juniper equipment, okay? And if you look at the numbers, statistically they probably will not be using Juniper SRX devices. So it's good to get your feet wet if you can, and maybe consider GNS3. As a matter of fact, at CBT Nuggets, Keith Barker has just finished up a series on the GNS3, and he also has some micro nuggets that show you how to use a wide variety of different platforms in GNS3. That may be a solution for you as well. Again, getting your hands on the code, that's up to you, okay? As a disclaimer, I'm not going to recommend that you go and try to find images out there. That's your thing. But the GNS3 may be a good option for you because it'll be a lot less expensive than going out like I do and having a rack full of equipment. That being said, let's go configure our 100 here at our remote office lab. I want to take two different strategies here. First, I'm going to show you the rapid deployment method going through JWeb, okay, logging into my SRX 100 and going through the JWeb interface to configure this. And then I'll go down under the hood and show you some of the configuration in the CLI. So let's go ahead and log in here as root with my password, Nugget Lab. Let's go to Tasks, and then configure VPN and launch the VPN wizard. Okay, I want a site-to-site VPN. Notice that it's route-based. That's the default option, which again is more complex, but not so complex if you use the graphical wizard-driven method, but it is more flexible. So we'll click on Start. The VPN name will be Nugget Lab. The local private network is on the trust zone. We'll choose the trust zone, put in the IP address of that network, which is 1.0/24. We'll add that. We could add more networks there if we wanted to. And then the interface, we'll give it the first logical number, so ST0.0. The interface zone is the untrust zone. That's where the secure tunnel interface is, on the untrust. And we'll go ahead and leave it unnumbered. The public network is on the FE000.0 interface in the untrust zone, and the interface type is static. I've actually got a static IP address assigned to that, 209.165.200.1. Click on Next. The remote gateway public ID of the other device, okay, like I said, it could be another SRX, but it could be a wide variety of devices, anything that supports IPsec, okay? So mine is 209.165.200.2. And the remote private network is actually 192.168.2.0/24. So the local network is 1.0, the remote network is 2.0. Go ahead and add that and click on Next. Okay, so here's some of our VPN settings, and we're actually going to see how we can configure this in the CLI here in a moment. In the wizard, we get three options: the basic, compatible, and standard. We're going to go ahead and stay with standard, which uses Diffie-Hellman Group 2, Triple DES, and SHA-1 for our hashed message authentication code. So Group 2 to generate our shared secret keying material, Triple DES for our encryption, and SHA-1 for our hashing and integrity mechanism. For IKE mode, since we're going over an untrusted network theoretically, okay, we're going across a point of presence or a ISP, for example, you want to use main mode. It has more steps, but it also includes peer identity, and it's going to be more secure over untrusted networks. Then a pre-shared key. Mine is 1, 2, 3, 4, 5, 6. Okay, not very clever, but that's what I have configured on both sides. So this is IKE Phase 1. Okay, basically it's IKE version 1, IKE Phase 1. That's what we're doing here. Remember, this is the Get Smart cone of secrecy or cone of silence, right? Okay, and then down here is IPsec settings. This is IKE Phase 2. Same thing, we have basic, compatible, and standard. So we're going to stick with compatible, ESP, triple DES, and SHA-1 for IPsec or IPsec Phase 2. Now, we're getting into some of the area here where I mentioned earlier, and so there was a method to my madness. One of the reasons why I went through and said, you need to pre-deploy and think about some of the things you're going to do before you deploy this. Well, one of the things is, are you going to use perfect forward secrecy? I'm going to go ahead and do this because it's more secure. Now, perfect forward secrecy actually is going to generate or go through a Diffie-Hellman process every time you're creating a new security association. So instead of reusing keying material that's generated from the initial Diffie-Hellman algorithm mechanism, we're going to go ahead and run Diffie-Hellman every time we have a new IPsec transform going on. We also talked about, are you going to do VPN monitoring? Are you going to do dead peer detection? Probably in a real world environment, doing both of these options would be a good idea. What I might recommend that you do, though, early on when you're just configuring this and setting it up, let's leave off the monitoring and the dead peer detection till you have basic connectivity, IPsec Phase 1 peering, and then actually you're transforming or you're encrypting and decrypting traffic via IPsec. Then you can come back in and turn on VPN monitoring and dead peer detection. Let's click on Next. Next, we have a very interesting area, and this is something that you're going to want to think about. Initially, when you're trying to create this for the first time, you may want to go ahead and stick with the defaults of just saying any. So from the private network to the public or outgoing from my internal LAN out to my other site SRX or whatever the appliance is, we'll go ahead and allow any application, and then from the public to private, any application. Now, typically in a real world environment, I don't mind doing any here. I don't mind any application going from the private to the public. But from the public to the private, I want to be very careful here because remember, we aren't really always sure who's on the other end of the tunnel. Okay, we can add other mechanisms like extended authentication to a Active Directory database, an LDAP server, some AAA solution using Radius, so we can also apply other layers of authentication and authorization. But you may want to limit under the profiles area what you're going to allow them to use, right? What applications, because maybe you just want to allow web traffic now or FTP traffic. So you could just add FTP, you could add HTTP, HTTPS, maybe allow all of ICMP or maybe just ping. And you can see you can get very granular with ICMP 6. Okay, ICMP 6 is very important because it replaces in IP version 6. It replaces ARP, so we don't have ARP anymore. We rely heavily on ICMP v6, but definitely things like IKE, possibly IKE NAT. You definitely got to allow IKE. So if you're not going to say any and any, IKE has to be in there for this for this tunnel to be created, right? And then maybe you could go down and see some other stuff. You can see other applications, but we'll keep it simple right now and just do any, and click on Next. Then we see kind of our review before we commit this. Okay, so the VPN name is Nugget Lab. The local zone is trusted. There's our local network. Our secure tunnel interface is ST0. The interface zone is trust, and it's unnumbered, so we're just going to use whatever IP address is assigned to FE000 unit 0. It's family INET, by the way. And then the public is untrusted, and we have a static assignment of IP address. Our remote gateway, the other device, the other SRX, the outside interface, okay, of that other device, the SRX, the Juniper router, the Cisco router, the adaptive security appliance, the checkpoint server, whatever it is, that outside address, okay? The remote network is the 2.network/24 on the other side. So my connectivity in my lab here will actually be between a device on the local network at 1.2, which is actually this workstation I'm on right now recording this nugget, to another workstation at 2.10, okay, on the other side of that SRX. And you can see our pre-shared key, it's main mode. We're not turning on dead peer detection or VPN monitoring, but we are doing group 2. And then you can click on commit. Okay, so it tells me that the commit was successful. Do I want to create a new VPN? And that may be the case. If I'm configuring this on the head-end device, I may be creating VPNs to multiple branch offices, multiple extranet partners, business to business, whatever, and just set these up with the wizard. I'll go ahead and click on no. And now in IPsec VPN down here, under Auto Tunnel, I can see here's my phase 1. You can see what it's named it, okay? It basically took my name and created a gateway, right? It created a gateway called GW underscore Nugget Lab. The IKE policy just takes IKE underscore Paul underscore Nugget Lab external interface. Okay, phase 2. There's the Nugget Lab VPN, the gateway. So the wizard creates the gateway for you, okay? You can, and it uses a default proxy ID feature, so it's very, very, user friendly, okay? There's the IPsec using perfect forward secrecy group 2, the proposal information. So you can get your IKE phase 1 and IKE phase 2 information here. And IKE policy, by the way, go back to that, main mode, pre-shared key, proposal information if you want to see that. So that's a rapid deployment of a site-to-site IPsec VPN. If I were going to do this in the CLI, there's several phases. Okay, I have to do IKE phase 1, IKE phase 2. I have to create a gateway. And if I'm using, let's say, a routing approach, I need to have my routing configured. If I'm using a policy-based approach, I actually have to use my policy. And I'll actually show you some of the syntax here if you're going to do the policy-based approach. So let me go ahead and get out of here. Okay, let's go ahead and then ping over to a workstation on the network behind the other SRX. So it's 192.168.2.10. And okay, so I can ping through it. I can ping through the secure tunnel to the other side. I can also go, let's get rid of this, and do a show config. And I can see here down in my configuration, we should be able to see our VPN. There's our ST0, okay. Got some static routes in there. Here's our security. This is IKE. Here's our policy, main mode, our proposal set, pre-shared key that was 1, 2, 3, 4, 5, 6. You can see it's been hashed. We've got a gateway called Nugget Lab, IKE policy, address of the peer, okay, 200.2, external interface on this one, and then you can see our so this is IKE phase 1, and this is IPsec or IKE phase 2. You can see we have perfect forward secrecy using Diffie-Hellman group 2, and we're binding to the ST0.0, and then there's our gateway and our IPsec policy information. Okay, I can configure this also in the CLI by going into global configuration mode and getting in and doing things like, edit security IKE. That's the main set. Edit security IKE. And you can see we can do our proposal, our policy, our gateway. Okay. We can also do edit security IPsec. And you can see under IPsec we've got policy, proposal, and VPN. Those are the two main areas. So edit security IKE is IKE phase 1. Edit security IPsec is IKE phase 2. So you would do your proposal first, then your policy, then the policy uses that proposal. Now it would take me, this is a ton of commands, okay, a ton of commands to set this up. So let me just show you the configuration and walk you through it. I'll also put this as a document up at nuggetlab.com, that's CBT Nuggets, and you can download that as well. So let's take a look at this. Okay, so let me bring this over here. This is you can see it's a pretty long configuration, okay? And I'm not a really super fast typer, so it would take me a long time to type all this in. So what I want to do, though, is kind of show you the main major steps. So first you'll configure your IKE phase 1 proposal. Then you'll configure your phase 1 policy with a pre-shared key in main mode. Then you'll configure your IKE gateway with a static IP and optionally dead peer detection. You'll configure your phase 2 proposal. Once you have your proposal, you'll configure your IPsec policy that defines the using of that proposal. Then you configure your site-to-site VPN. And then finally, if you want to do a policy-based, here's the configuration for a policy-based, which you can see we're going to edit security policies. So you're just basically doing a policy, the from zone to the untrust zone, ROBO, remote office, branch office, outbound, and you're setting the match of the source and then destination, and then set the tunnel, okay? And actually this has one too many tunnels in there. This is one thing I mentioned to you, by the way, about policy mode, is that it uses the keyword tunnel. If you were doing routed mode, it would just be set then permit with no tunnel keyword. Okay, so let's go just real quickly back to the top here. Like I said, I'll make this available to you in RTF format. You can download it and you can go through it and use it as a tool to do your own configuration in the Junos CLI, or you can use it as a test prep tool. But you can see in the first step, we're editing our IKE proposal. Okay, so I call my IKE proposal Robo, Remote Office, Branch Office, Pre-Shared Key. So that puts me into this edit mode, right? And then now we'll set the authentication and say we're going to use pre-shared keys. We're going to use Diffie-Hellman Group 2. Our encryption algorithm, I'm using triple DES CBC in this example. The authentication is SHA-1. The lifetime is 1 day, 86,400 seconds. Then you can do the show command to see the results, and then do top commit. Top commit will take you to the top, edit, and then it will commit it. Okay, then you're back in edit. You can do configuring your phase 1 policy with pre-shared keyed main mode. Okay, so it's edit security IKE policy, calling it robo static, puts me in this mode. So I'm setting the mode to main mode. I'm setting my pre-shared key, it's ASCII text. My key is Nugget Lab in this example. I'm setting my proposal to robo PSK. This is the proposal that I created up here. Okay, so I'm invoking that proposal, robo PSK. Do a show command to see it, and then top commit, and then you have that part done. So that's IKE phase 1. So then you'll do your configuration of your gateway. All right. So we edit security IKE gateway, calling my gateway robo 1. You got to have a gateway. Okay. The JWeb, when I went to the wizard, it created the gateway for me, kind of automatically without even asking me what I wanted to do. So you're setting the address of the gateway. So this is the address of my outside interface. External key gigabit 00, it may be gigabit. This is actually a script for a SRX, a higher end SRX, my 210, which has a gigabit. So for my 100, it would just be fast 0. Setting your IKE policy. My IKE policy is the same name as my gateway. Doesn't have to be, but I find it easier to do that. Okay, I'm setting dead peer detection, 10-second interval 3 times. I'm going to try. Then do the show command and then top commit again, which takes me to the top and then commits it. And now we're still in the edit mode where we can configure our phase 2 proposal. My phase 2 proposal is going to be called remote client. Issue that command. It puts me in this mode. I'm setting the encryption to AES 128. I'm setting the hashing to SHA-1. I'm setting the protocol ESP as opposed to authentication header, ESP. Setting my lifetime, 3600 second lifetime. It's a good lifetime for IPsec or IKE phase 2. Then you can show your configuration. Here's my phase 2 proposal. So you can see that my policy is called remote policy. So my proposal is called remote client. My policy is called remote policy. Issue that command. I'm now in this configuration context, and I can set my proposals to use remote client, right? The one I created up there. Remote client. I'm setting perfect forward secrecy. Okay, here we're doing group 5, but if I want to do group 2, just put in 2 there. Then show, and then top commit. Then configure your site-to-site VPN. So I'm calling my VPN Robo VPN. Okay, so I issue the edit command. I'm in this context. I'm using my gateway, Robo 1 gateway. My policy, IPsec policy, remote policy. Those are 2 constructs from above. I'm saying I want to establish my tunnel immediately. I'm also clearing the DF bit. So that's the do not fragment. Don't fragment bit. I'm clearing that. I'm also setting no anti-replay. So by default, this is going to fragment and it's going to do anti-replay. I'm turning those features off. Okay. Then you configure your policy-based VPN. Create a couple of address book entries for inside networks and remote networks, and then you're going to go and you edit your security policy from zone to trust zone. The policy is called Robo Outbound. This will be a policy that will be added right to all of your other security policies. So that's the thing about policy-based. It's just another aspect of your security policy. Okay, here we're only allowing the Junos HTTP application. Remember we saw that in the graphical interface earlier. You could choose your applications. I just chose, you know, any. You'd probably want to do more than just Junos HTTP. You probably want to add IKE in here as well. So IKE and HTTP, right? So I'll put this script up on the nuggetlab.com website, and that'll help prepare you for anything you see on the exam that's going to ask you questions about configuration in the CLI. Okay, so rapid deployment in the JWeb and CLI, you can see how many commands were pushed over from the JWeb to my SRX by looking at the CLI configuration. Alrighty, I hope IPsec VPN Part 2 is informative for you. I want to thank you for viewing.